right, guys. Super excited to have my next guest on the Ravit Show. It is none other than Tomás Sabat. He is the Chief Operating Officer at Vaticle, creator of TypeDB and TypeQL. He works closely with their open source and enterprise users who use TypeDB to build applications in a wide number of industries, not only limiting to financial services, life sciences, cybersecurity, and supply chain management. So today we'll be talking a lot around TypeDB, TypeQL, and obviously we'll be talking about open source. So be ready with your questions. You have a chance to win 2 annual subscriptions of 365 Data Science. If you put hashtag 365 Data Science in the comment section, I will be doing a giveaway in between the session, and by end of the session, there'll be 2 lucky winners. So before calling in Thomas, I would like to thank our partners, 365 Data Science and How to Get Analytics Jobs by Albert and John. So let's have Thomas here. Hey Thomas, welcome to the Ravit Show.
Thank you. Good to be here.
Awesome. I was just letting the folks know about what all we'll be discussing today. Obviously, we'll be discussing about TypeDB and TypeQL, definitely about open source, can't miss that. And so yeah, can you tell us something about yourself, Thomas, and where you're coming from?
Sure. Well, first, thank you for having us. I'm currently calling in from London. We've been experiencing in the UK a lot of very hot weather. So this part of the world is great at heating, but when it comes to using air conditioning, it's not so great. So it's been rather hot most places, both in the office, but we do have AC, but that's currently what's going on now. But yeah, no, I work as the Chief Operating Officer at Vaticle. We are the creators of the database TypeDB, and I guess for myself, I'm a bit of a mix in terms of where I come from. I was born in South America, in Chile. My father is Chilean, but I then also lived a few years in the Netherlands, so I'm a bit of a mix of Dutch Chilean before I moved to the UK. Yeah, that's a little bit on myself.
Awesome. I think we all are waiting. We all were waiting for this. And to start with, can you tell us about a little about Vaticle and also about what services you guys provide?
Sure. So as Vaticle, we build TypeDB. So TypeDB is a database. Specifically, it's a strongly typed database that empowers developers to effectively work with complex data more easily and ultimately help solve some of the complex problems that are out there. We started the company actually already 6 years ago. So we've been doing heavy R&D for, well, all those years, and started actually originally in Cambridge in the UK. Heiko Pribadi is the main founder, and he initially had the idea when working actually at the scheduling optimization company based in the Netherlands, where he worked on optimizing some of the largest supply chain networks and trying to optimize those supply chain networks, which actually requires a lot of modeling of very complex data. But yeah, we developed this new type of database where we've built this very expressive type system that allows developers to work with complex data more easily and build software faster, and enable effectively the creation of use cases that otherwise wouldn't be possible. We are open source, so a lot of the work that we do is in the open source community. We see most of the use cases in the life sciences, so things like drug discovery, precision medicine, but also in other industries like cybersecurity, financial services, even stuff in the blockchain industry, actually, which some of the uses quite surprised me, to be honest. But any industry really that works with that has to first integrate, that means effectively modeling very complex data or effectively very heterogeneous data sets, which requires you to model that data in a way that captures all of that information while staying simple enough for us to understand what the code is saying, and then actually being able to query the data in a simple and easy way. And yeah, I mean, we released our latest version, a major release we had a few months ago with our 2.0 that was released. That was the big actually re-architecture of the software to effectively increase performance. But yeah, we're excited. We actually have shifted a lot of we do a lot of events because of the open source community, and we were meant to come to Bombay and also Mumbai and Delhi in February 2020. So as the pandemic started, we actually had it all planned out. We were going to Delhi, to Bangalore, to Mumbai, but then of course we canceled the trip because of the pandemic. So I would say as soon as the pandemic is over and it's safe to come, we'll definitely come visit you and over there and do something together.
Definitely, can't wait. We have a few people also joining us here. So Suresh is here. We have someone from London. Okay, Andrew Jones, my man. He's the owner of Data Science Infinity. So he's here. We have Manisha Jain joining in. We have Aditi is joining in. Hello, everyone. So everyone's here. We are all set. Thomas, thanks for that background about you yourself, about Vaticle, about what you guys are doing. So if I have to ask, you are the creator of TypeDB. What can you tell us more about it? How did this happen? Or was this planned that, okay, I'll be the creator of some database? You already had this planned. Or how did it, what was that first glimpse of, you getting there?
Yeah, so I mentioned already Heiko. So Heiko, who's our CEO, and he leads the technical vision, and he's the originator of the database. So the story really goes back to Cambridge, actually. So both me and him, we studied in Cambridge at the same time. He did a master's in computer science, and he's fascinated by maths, and so he took classes in knowledge representation and automated reasoning, just as a out of interest, really. Later, he then went on to work at a very, very large scheduling optimization company based out of the Netherlands, and that's where he got to work on some of the world's most complex supply chain networks in the world. So think large airports, large supply chain companies, coal mines, in order to optimize those schedules effectively, you have to first model all of that data into the database. So what they would do is that they would spend months actually first modeling the data effectively in tables. So the result is you end up with thousands of different tables, which is incredibly, first takes a very long time to do, but not only is the modeling very difficult, you also end up with queries SQL queries that end up being hundreds of lines of code, and that's just very, very difficult. And back then, graph databases actually did exist, but for various reasons. For example, there's no schema enforcement in a graph, and also the graph model itself is very low level. They did not use any graph theory. So that's kind of where Heiko at least was introduced to this problem of complex data and modeling of this, and the fact that there's no actual tool really that can model that data in a simple, elegant, and expressive way. Now, after fast forward to later, he joined forces with our first investors, and that's kind of how the company started. But the idea was effectively to take that maths, the knowledge representation, the automated reasoning from this class that he took at university in Cambridge, and actually leverage that science to build a new type of database. And actually, originally, not many people know this, but the original story is that we initially planned to build what was effectively an ontology-driven search engine. It wasn't actually meant to be a database. So leveraging effectively a very expressive ontology to build a very powerful search engine. But once the first version of that was built, the performance of that was actually really, really good. And we decided to actually just pivot, just become a database, period. And also at the time we were actually called Mind Maps. That was the first name of the company, but well, Mind Maps is not a great name when it comes to SEO. So that's why at the time we actually rebranded to a name that we changed afterwards again, called Kraken, and just not too recently, we actually renamed again to Vaticle, and I promise that's the last time we're doing that. I can get into why we did that branding change in a second, but basically the premise is just really how to leverage knowledge engineering, knowledge representation, and build a database that can actually take those approaches from symbolic AI, because those are effectively subfields within the larger field of symbolic artificial intelligence, and build a language that is very, very elegant, is very simple to use, gives you the power of inference, the power of type inheritance, all of these beautiful concepts that are incredibly useful, but giving them to the developer in a way that they don't need to know about symbolic AI, about knowledge engineering. So that theoretical background for you not to having to know that. So when you're using the database, you just really need to know about what an entity relationship model is. And that's why the model itself, the language, in the language itself, we implement directly an entity relationship model. That's the core model in the database. So you know how when you're modeling any schema, let's say in a relational database, you start with your entity, with your concept level schema. So you define what are your entities, what are your relations, what are your attributes. And normally you would go through a normalization process to get to most commonly third normal form to get to your tables. And then you implement it in code into your database. What we're saying, what it means, what I'm saying is with TypeDB is that rather than having to go through that normalization process, we actually don't need to do that normalization process at all, because we skip out that process, because the concept level schema is actually the schema itself that is implemented at the database in TypeDB.
Mm-hmm. I think that kind of ties in with one of the questions by George Ferrikin. So George had a question which says, what are the benefits of TypeQL over SQL or no SQL? So how would you say that?
That's a big topic, I should say. But firstly, I will add, I actually gave the keynote at our conference last year is actually on that very topic. So there's a talk, we were called Kraken. So if you Google for Kraken Cosmos comparing SQL to Grackle, which was the name before we changed to TypeQL, there I go in depth as to that topic. So we look at a lot of code, and if you want to sit down and actually have an answer that's an hour long, watch that. There's also articles and there's some documentation. But the short answer is the one that I just gave. So you can either model things at a concept level schema, and then normalize that to the logical level, which is effectively in tables and what SQL is great for. But what we're saying is that when you do that normalization, firstly, it takes time to do that, but also there's a lot of semantics that actually are that you lose a lot of semantics when you go through that process. Now, SQL and relational theory in general, the beauty of it is that it created this physical independence of data. Because before, and this is really goes back to the 70s, before we actually had to, if we wanted to retrieve our data, back at the time in the 70s when we had hierarchical databases, network databases, you had to write some sort of linked list to actually retrieve and to know physically where the data is stored. And so the beauty of relational is that it actually created an abstraction layer over that. And that's why, as beautifully as the giants of the space say, is that relational gives us this physical independence of data by modeling things at the logical level. Now that's really great, and that's really one of the core powers of relational and SQL is the query language. But what we're doing is effectively standing on the shoulders of SQL by going another layer of abstraction, which is effectively saying we abstract away even the logical level by modeling things simply at the conceptual model. And so in terms of modeling, that just gives you a much richer and much easier way to model actually things directly at the concept level schema. And then there's more specific things like TypeDB, TypeQL is a language has native support for things like hyperrelations. So a hyperrelation is effectively a relation that has n number of things in the relation. There's also rule-based inferencing in TypeDB. So there's an inference engine in the language itself. You don't have that in SQL and relational. Neither do you actually in NoSQL. And if we generalize NoSQL as being, whether it's key value pairs Mongo, whether it's graph databases. The key distinctions, the key core aspects of TypeDB is that it provides incredible expressivity through that concept level schema that I mentioned. The second is effectively safety. So type safety, because of the type system, it implements schema constraints on write. So you have to define your schema, and but it also, when you're writing an unsafe query, it will also tell you. So if you're trying to write a query that is not safe, as in it doesn't adhere to the schema, rather than being returned an empty set, which is what you get in Mongo or in a graph, for example, you're going to get an exception to say that this is wrong. The third point is the ability to do inference. So specifically, we provide type inference and type and rule-based inference. And the fourth and final point is that because of all the semantics and all the information in the type system, their query planner is able to optimize the query paths much faster and effectively give better performance because of that.
I think this is kind of, yes, obviously, like you mentioned, it is a whole lot of big topic out there, but then I think definitely answers George's question. And there was another question from Manpreet here. How can we have a good data documentation tool to help other business partners and teams understand the value of data and how we can make effective ones?
That's a great question. I think one of the difficulties, the general difficulties in most businesses, especially where decisions, some of the higher level decisions get taken by people that aren't perhaps directly exposed to the data infrastructure itself, is that the ability to, first having an appreciation of how important it is to model your data in the right way. And so there's this disconnect between the database and the people both building code at the application level and also the business people. So one approach that we're taking is that one of the most important things that we've done, that we've decided to spend our lives on doing, is to building a language that is nearly human readable. So the language in TypeQL is that, as if you're a subject matter expert, that if you look at the schema, you can make sense of it. And that's really important, because the people that are making those decisions, that are a business partner, for example, that there's no way they're going to understand if you get them to write SQL, they're actually going to understand, at least in a high level sense, what the model is trying to do in TypeQL. And that's why for us it's so important to have this balance between how expressive is the language, like effectively a database language, versus how simple or complex is it. Because it's very easy to make a language very complex, but very expressive. But it's very difficult to keep it simple. And so that's where we've really tried to excel, to make a language that's beautiful, that is elegant, simple, but also insanely expressive with what you can represent. So I think that's a really important part, to understand how your data is modeled and what are the queries that you can get out of it, because that affects directly the business value that you get in the form of what answers can I get from my database.
Yeah, definitely. And that kind of answers. Interesting question from Manpreet. Thanks, Manpreet, for that question. Clears a lot of things. Also, I had an interesting question for you, Thomas. Asking about the big machine here. So what are you guys actually trying to solve for your customers? If I'm a customer out there, what is the exact problem that you would want to solve for me?
Well, I mean, ultimately, the lowest level is that as organizations grow, mm-hmm. and as data grows, not just in size, but in complexity. So imagine, organization with dozens of different types of data sets. Simply asking a question that touches a few of those data sets becomes really, really difficult, because the data has different schemas. Well, some may not even know what the schema is for. And so as this complexity grows, the ability to actually have that data represented in a format that you can ask questions and get answers from that becomes extremely difficult. And so in whatever industry we are in, that the questions will be different, but ultimately the use case will be the same. Is that as data becomes more complex, and by complex here we mean there's more types of relations, there's more types of entities, the more difficult it is to just get an answer for my question. And it can be as simple as, you know, a 360-degree view of all my customers. And so at a fundamental level, that's really the core problem that we're solving. And, you know, to go even higher level, computer science generally moves when it creates abstraction layers. If we think of Python is a very high level language. Python compiles it to C. But if we go all the way down to binary code or just assembly code, where we were a few decades ago, no one's going to be building a self-driving car with assembly code. If you do a print statement in assembly code, you're writing 50 lines of code versus just one line of code in Python. So the history of computer science is also one where we create abstraction layers. And the last time we created a real abstraction layer at the database level was back in the 70s with relational. NoSQL has really just solved the problem of scalability, which is a big one, and that has been solved successfully. But when it comes to the problem of dealing with complex data, it's an inevitability that is to be addressed. And so whether it's us with TypeDB, it's simply really just the natural evolution of the industry.
Awesome. I think that kind of answers my question definitely. And also, Thomas, I wanted to know about a little more about Vaticle. Obviously, how does it feel to be a part of Vaticle, and how long it's been now with Vaticle?
Well, I think when you join our team, one of the things you'll notice is that everyone is highly driven with a purpose, and that's also something that we look for. People that are driven, that lead a purposeful life, and they want to have a life that actually is meaningful and can shift the world just by a tiny bit. And the reason I say that is because when you join our team, whether it's in the community side of things, whether it's on the engineering side of things, you're directly exposed to our open source community. So every single day, and if you go to our Discord forum, every single day there's people developing with our technology, asking questions. Those questions may be as simple as, you know, I can't install Kraken, I've got an error with TypeDB, help, or they can be more elaborate in that they're trying to model this very complex, you know, protein structure, and they're struggling to know how to call this relation. So you have a direct view into what other people are doing, and that requires everyone to have a passion into actually making the world just a better place, even just a little bit. Because when we enable others to build software that solves real problems, you know, that really means something. You know, for example, a biotech company trying to find a cure for certain autoimmune diseases, that's what you really get to work on, and you really see the fruits of your labor, not physically, of course, because it's still just software, but at least you see them in the community, you see them presenting, and so that's incredibly important for us to have. Now, we do set the standard very high, though, because in order to do what we do need the best people in the world to join our team, because the challenges are also formidable, and so joining a team here is always. As you know, as some have described it, is sometimes some of the challenges that some people may have is that in other companies they may have been the smartest person in the room, but here they're just one of many, and so that's also what we look at, what we look for people that are able to be challenged, are coachable, and so it's very important for us to embody those values, because really everyone in the team has a front row seat with the community and gets to respond to people on Discord or on the forums.
No, I think definitely that is kind of helpful, because that culture is kind of brings in things along very well. Community building is one of the most important things that I think every company is looking forward to. So thanks a lot for that information, Thomas. And now the exciting time comes up, obviously, since we are going to do a draw giveaway. So Thomas, for the people who are attending, you guys can actually put a hashtag 365 data science, and here we go for the first draw. So yeah, we have 6 entries already. So that's what we're gonna do, a giveaway for. All right, awesome. All the best, everyone. So the first giveaway, who's the winner? It is Krish, Johan. So, okay, John, congratulations. I've reached back to you. So, continuing our conversation, there's more for the audience. Obviously, it continues, and there will be a last giveaway. Hashtag 365 data science is something what you can use, guys. And Thomas, obviously, there's one question for you, which is very interesting by Manisha. Hey, Thomas, which is your favorite open source database except TypeDB?
So, that's a great question. Well, I think I should say something that we actually use under the hood. So the way TypeDB works architecturally is that we persist data when we write things to disk in RocksDB. And so RocksDB is an open source database. It's developed originally by Facebook and was made open source, and it's incredibly scalable, or incredibly performant, but also very, very low level. So it really gives us a lot of benefits when it comes to getting the most performance out of TypeDB. And to explain that further, so TypeDB as a software embeds as effectively as a library RocksDB. So we use different types of open source libraries, and one of those is RocksDB. But RocksDB can also be used as a standalone database, which, by the way, is something very common for database for effectively database to leverage libraries that can store things into disk, for example, and we leverage RocksDB, and we've been very very excited to be using them as well.
Yeah, definitely. I think that makes sense. And also, there was an interesting question from Kalyan Prasad. Kalyan is asking how TypeDB helps in translation of high-level queries into low-level.
Yes, so this is very important just to understand. When we talk about high-level and low-level, what that means is that the language that you use to write to the database to represent your data is all done in TypeQL. So when we talk about translation, there isn't a translation per se. It just means that the language itself is higher level in the sense that there are certain operations that effectively are abstracted away. So the way that's done is effectively architecturally, we have this type system that implements effectively the entity relationship model. So you model things with entities, with relations, with attributes, and then under the hood, and that as a developer, as a user of TypeDB, you don't see that. You don't have to really know that when you're using it. But what happens is under the hood, that gets then translated into a binary graph format, and we have under the hood we have our own custom-built graph, effectively a graph database that we build just custom for TypeDB, and then that gets persisted into key value pairs in RocksDB. So architecture, and then that's a very simplified version of what happens under the hood. That's basically what's going on under the hood. But as a developer, you don't have to worry about, you don't have to think, you just use the language TypeQL to query for your data, to represent your data. If you do want to know more about the architecture, though, I would recommend watching Heiko's talk at effectively the keynote at our conference, at our virtual conference last April, and where he explained basically also the architectural changes that we've made with the introduction of 2.0.
Awesome. I think that definitely helps, Kalyan. And also there was an interesting question from Amber Gupta. What was the first thought of creation of TypeDB? How did it come to your mind?
Well, I think I kind of referred to that during the earlier answer. So Heiko's the original author of the software, and the underlying math that forms the inference engine, that forms the knowledge, the type system, which is really based on principles from knowledge engineering, so things like symbolic artificial intelligence.
Definitely.
a lot of that came from Cambridge, really, where he was very much took a course effectively in knowledge representation, automated reasoning, and that formed the basis really of a lot of the inspiration that then led to the actual creation of TypeDB. I mean, it's a long story because actually, rather than building a company, Heiko actually the initial plan was to do a PhD in Oxford and to build this as an academic project. But luckily, that didn't happen.
Wow, and company got formed. That's amazing. So awesome. Also, talking about, we were just talking about the community. I had this question. What do you think? Why is the community, maintaining? How do you maintain yourself? You keep yourself open source at heart. How is it important for Vaticle, and what are the challenges?
Sure. So something I think what's really important is for, first and foremost, for us as a team to have an inherent passion to want to help other people through the open source. So that's kind of the first principle where we come from, because you want to help someone that you don't know that's asking you questions. And to be perfectly honest with you, some people can be quite rude as well. They expect a response as soon as possible, even though they're not a customer, they're just an open source user of your technology. So you generally want to help because you feel that you can really do something that's greater than yourself. And then really an understanding that ultimately the community itself is more than just the sum of its parts. Because when you get people in the community talking to each other, collaborating with each other, they can inspire themselves, they can build tools that help each other. And so in a way, our role is really just to facilitate those interactions, to showcase firstly the passion that we have and the emotion that we have when we effectively do our events, do our webinars, the way we conduct ourselves in the forum, responding quickly, trying to really help. That's what starts. That sets the example for other people to feel like they want to be part of this. And so having people feel like they want to be part of something, of a growing early stage community, that's something that's really important to effectively help catalyze. So if any of you that's listening is interested in being a part of that, just join the community. And especially Daniel is a community manager. He's extremely active and he's happy to chat to anyone really. As a side note, I don't know if he's watching this, but he also has a very cute dog, and he'll be happily share pictures of your dog. If you want a tip on how to connect with him and befriend him, just say nice things about his dog. He'll be your best friend. So I think that's really important. In terms of challenges, now ultimately we are a company, and so we are, we raise funds, we raise investment to I see that Daniel is listening indeed. So we are a commercial entity that is behind developing the database, and so sometimes it's hard for people to appreciate that ultimately, the money needs to come from somewhere. Now that's ultimately our responsibility, and we build the open source community in a way that is not, commercial doesn't come first, but there needs to be a healthy pathway for the company to ultimately make money in the way that MongoDB or Databricks or Elasticsearch or any of the larger players have evolved. And that requires having effectively from a product strategy, understanding what are people willing to pay for, what are people willing not to pay for, and also treating their community respectfully. So, and I think one of the big shifts that has happened in the last 10 years is that I think a decade ago people were very antsy and very allergic to pay anything for open source. Especially with the cloud appearing, that is changing significantly, and that's what we're seeing a lot also helping us basically to build a business where people are willing to pay for, whether it's a managed service, whether it's a product that has more features and pay for that. But navigating that is always a challenge because you have to be very careful. You can't, for example, have a feature that's open source and then suddenly make it closed source, because that's going to piss a lot of people off. And so it's just being very mindful of what people think. Ultimately, as a team, we are engineers ourselves, so we can't put ourselves in the shoes of others, of our users, because we're effectively the target audience. But always being very mindful of that. Luckily, there's been there's been some companies that have come before us, some of the ones I mentioned, and so there are actually a lot of lessons to be learned from them, because As with any organization, they've made mistakes, whether it's in the legal licensing of things or in the way you treat your community, or whether you make everything open source in such a way that there's no way that you can actually charge for any product. So those are things for us to think about, yeah.
Awesome. I think that definitely is very true, and keeping community intact and you putting yourself in the opposite person's, your client shoe, is the key. So yeah, talking about that, also coming back to TypeDB, strongly typed database or knowledge graph is something what I wanted to ask. But TypeDB can be used as a knowledge graph, a knowledge base graph, a knowledge base and a database. So, or is it all three of them? What is it?
So it's a good question. Now, fundamentally, the definition of what a knowledge graph is, what a knowledge base is not exactly defined. So it usually, the answer to this question just depends on who you ask. Now, as an organization where we're trying to educate the world as widely as possible, we try to also appeal to as many people as possible. Now, TypeDB can be used for any of those. Now, what does that mean? Now, firstly, in knowledge base and knowledge graph, both terms can actually be used interchangeably. The way we define a knowledge base is effectively a database that has effectively very richly semantic data, effectively contextual data represented in the database. So rather than just storing data, we're storing knowledge. Now, usually that happens in the form of a graph. That's why the terms both knowledge graph and knowledge base, in our view, can be used interchangeably. The way we've shifted as a company is that the idea of a knowledge graph is that really of a use case when you're trying to effectively create a knowledge graph, a company-wide knowledge graph where you're representing a lot of disparate data sources. But I'll be also very frank and admit these are just terminologies that is ultimately just semantics. Ultimately, what I always say to people is that you have a problem, you need a technology to solve it. Doesn't matter what it calls itself. We call ourselves a strongly typed database, but I would even argue focus on the features. What does it really do?
Yeah.
And on that basis, decide whether it's something you want to use or not.
Awesome. Yeah, I think that definitely makes sense. Also, if I had to ask you about the importance of type system in TypeDB, can you tell us a little about the use cases that excites you the most? So what would they be?
Yeah. No, so it's super exciting because firstly, type systems have been growing in popularity significantly. When you look at Rust, when you look at Haskell, when you look at the rise of TypeScript, the value of type system is quite well understood by the industry. And so a lot of those benefits are actually the core benefits that TypeDB delivers, but not at the programming language level, but at the database level. So if you understand the benefit of type systems at the programming language level, then you have a pretty good, easy time understanding the benefits of the type system at the database level. And so now in terms of what we can do with it, personally, I have a strong interest, especially in the life science type of application. So where TypeDB is used to represent and model a lot of complex biomedical data. So disease data, drug data, to find new drugs to cure diseases. That's where I always, I kind of pinch myself a little that we can actually help, if it's just a little bit, to even accelerate just a little bit some of these drug discovery processes. So those are the ones that I'm always very very thankful that we can work in. Yes.
No, exactly. It is obviously it kind of feels. I know I can only imagine the way you might be proud about yourself or about the team altogether. Where you guys are working in drug discovery. It's helping even 1% of it. It is superb. So great work there, Thomas, and obviously to your complete team. Also, since we are coming to closer to our time, I would want to ask you a few questions about, obviously, these are quick questions about something more than what you do. So if you talk about books, which are these books that you read, or which are your favorite books you would want to recommend to the audience in data
Yeah.
or in AI?
Yeah, I think if there was one book, and I'll just leave it to one book to have the maximum impact, I would say check out The Master Algorithm from Pedro Domingos. I think that's probably the most, it's a high level explanation, so you don't need to really understand much of the low level and how a Bayesian network works. It's a really good book where he really describes very succinctly, but very powerfully, how there's different tribes effectively in AI research, and ultimately how there has to be some sort of endeavor to link all these different tribes together. The tribe that we have our roots in, going back to the start of the company, is symbolic AI, which is one of those tribes. But then there's other tribes. There's the I forgot the exact names of all the other tribes, but other things like Bayesian networks or convolutional networks. Those are different types of intelligence, but a lot of this research is fragmented. So if we're serious about building intelligent applications, we need to bring all of these fields together. And effectively building a database like TypeDB is crucial in that, to effectively have one model that can allow you to perform learning algorithms over it.
Yeah, totally makes sense. Also, since we'll take one more question from the audience, but before that, I'll just do the giveaway. Final giveaway is here. So anyone who wants to actually type in hashtag 365 data science, please feel free to do it before I take the draw in. I will just take the draw now. I might see my own name here, but that's all right. I could be the winner. Okay, so it is.
Oh, almost you.
Oh, it's me! Wow! Okay, I just draw again for the audience.
It's your lucky day, Ravit.
Exactly. I should have asked for 365 data science folks to give me the annual subscription. It's Aman Kumar Jha. Congratulations, Aman. I'll reach out to you. But yeah, Thomas, it was fantastic talking to you. I'll just take one last question, since it was something what I also wanted to ask Surendra Jain. It says, where do you see TypeDB in next 3 to 5 years?
Yeah, thank you for the question. I think for us as a company, we're evolving into scaling up and growing more and more and more. That means both the open source community, that means also commercially scaling more and having more production deployments of the software. So we're looking to also bring out our cloud version, our managed cloud service of TypeDB. So a key part of that is really teaching the world, educating the world of the value of type systems at the database level, specifically in the form of TypeDB, and why that's helpful, and really effectively forming our own category in the database space. Because one of our challenges has always been the educational aspect of it, because fundamentally TypeDB is not a graph database, it's not an object-oriented database, it's not a relational database. So there's a lot of education that we take on to really teach the world on the benefits of it. So I hope everyone here gets to use the software. You can download it today. It's open source. Start building with it. Just do a project. Join Discord. Nag Daniel and his dog, and let us know how you get on.
Awesome. That's amazing. Thomas, if you have 2 minutes, can we just run the audience through your website?
Sure.
Yes, I'll just quickly, so people can know where they can. So this is the website.
Yeah.
Where everything's here. Your GitHub, Discord, Twitter, everything's out here. And these are the clients you have catered till date.
These are includes. Yeah, we've been very thankful with a large community of users already. Some of which we've known for 4 or 5 years already. Others that are newer, but it's always interesting when you speak to early adopters of technologies that there's this spectrum of people, and we've been very grateful with some of the support that we've been getting.
Awesome. I think definitely a great talk with you, Thomas. It was fantastic having you on the show. Thanks for all the information and the detailed summary about TypeDB, and thanks for being on the show again. Thanks, audience, for asking such amazing questions to Thomas. Can't wait for 2.0 visit of yours, Thomas. When there are more developments, definitely I'll be happy to invite you again.
Yes, thank you so much, and also good luck with the show.
Thank you very much. Okay, bye-bye.
Take care.